we are going to open the new family again, new family for the door, then scroll down and choose generic model, open, add, change or set the unit that you want. For me, I use millimeters. Okay, millimeters. Okay, then for a door, we need the width of the door, we need the depth of the door and the height of the door, but also we need the angle for our door to be operable or openable. So let's first create the reference planes. This one, horizontal ones, the vertical ones. Okay, so add the equality constraint so that each change we will be making, the distance will always be equal from this middle reference planes. So add dimension again here, then give them parameters. Let's call this door width, door W. Okay, let's call this one door depth, door D. Okay, so let's go to the front view. Okay, then we are going to set, we are going to add another reference plane as the height of our door, because we need to be controlling it as well. So let's call this door H for door height, door H, hit OK, apply. Then let's check in family types the door width. Let's have it, for example, as 600 millimeters, hit apply. So the door height, for example, 800 millimeters, hit apply. Then the door depth normally is about 25 millimeters or 2.5 centimeters. So 25 millimeters, hit apply, hit OK. So this is how our reference planes are looking. So let's create extrusion in front view. So create extrusion, lock it. Okay, so I'm so sorry, since we want to have this door to be opening, would like to add the reference, line, this one, and that reference line will be from here, or let's say here in the middle, no, here, and have it like this. Okay, then this reference line we can create a new subcategory so that we can change the color. Let's call it red, give it a red color, hit OK, give it the line pattern as the aligning line. Okay, so this, let's go to annotate angular dimension. We're going to add the angular parameter, this one, so that our door will be able to be opening and closed, to be opened and closed. So let's go for it. So this angular dimension is going to be called angle. Let's call it angle of opening and closing. Then align, you have to align this reference line to these reference planes and lock it. So you have to drag it back and forth, lock it, bring it back again, and lock it to this vertical reference plane and this horizontal reference plane. Okay, then we also want to have the door which will be closed and reach to the very end of our door width. Since we have the door width, we just have to select this reference line, come here to this dimension, select it and turn, give it a dimension, then select this dimension, go back here and choose door width. So this line will be equal to the width of the door, and on this line is where we are going to be extruding our door. So before adding our door, you can even check this angle. For example, let's give it a 0, apply. You can see that the door is closing. Give it 45 degrees, apply. It is opening. So far so good. So let's go to the 3D view where we will be modeling our door from. So let's give the scale of 5 so that you can be able to visualize our line. So create extrusion, but before, let's pick a plane. So you can use tab to change or to make sure that you are on the reference line. Select it, then create our extrusion on this line. So before closing, you have to align this extrusion to the very end of our line, of our reference line, so that the width of this extrusion will be locked to the width of this reference line, which is equal to the width of the door. So AL, choose AL on the keyboard or select this icon to align, then choose this end of the line, align it with here and lock it. Do the same here and lock it. So hit finish, go back to the front view. This is how our extrusion is looking like. Go back to the 3D. Then we have to change or to give parameter to this thickness or depth of the door, which is looking very, very big. So what I'm going to do is select the extrusion, then change the extrusion end, and let's give it a parameter and call it the door depth, which is already set. Hit OK. So the door depth parameter will be adapted to the depth of our extrusion as well. So go back to the front view and align this door up and down. So align it here, lock it, align it here and lock it. So let's go to the ref level. This is our door that we have. So we need to be able to open and close our door. So let's go back to 3D view. Let's give it a shaded property so that can be easily seen. Then go to our family type, change the angle to 20, hit apply, 40, hit apply. So you can see that the door is opening and closing very well. So let's close it so that you can add the handles very easily. So let's add the angles, the handles. So the handle we want to add, we need to go to the left of or right view. Let's choose the right view and add void extrusion. Create the void, choose void extrusion. Let's use this line drawing, then move 5 millimeters, then come down at about 40 degrees from the horizontal, 45 degrees. Okay, then trim these lines. Let's delete this one and hit OK. So this is our handle. In 3D view, our handle, yes, it has already cutted the geometry. So we need to go in the front view and set again the parameters for our handle. We want our handle to be beginning from the center, but we would like to control the length of the handle. So we are going to add the length of the handle parameter here. So let's call it handle length. Length. Hit OK. Hit OK again. So in the family types, you can change the length of the handle. So let's say 300 millimeters. Hit apply. Hit OK. So this is our handle. This is how it is looking like in 3D. So our door is done as of now, but we would like to add the material parameters. So do the same here, create new material and call it door. Let's call it door. So hit OK, hit OK. Then let's save it and call it, let's save this, our second family. Let's call it lower curb door. Okay, so let's load it into the lower cabinet shell. So hit OK, then place it here. So what we want to do, we want to add this door here and give it like the opening place, or where it can be opened. But first of all, we want to associate or bring the parameters of this door into this family of lower cabinet shell. So what you want to do, you want to select this door here, go here into edit type, then associate these family parameters. So click on this little square icon, so call it door as the material parameter. Then these dimensions, you have to call them or to add them as an angle. Okay, add this door depth and call it door D again as the initial name. So door height, so do this for all the parameters. Door width, door W, then the handle length, add it as a handle length still. Okay, so the second thing we want to do, you have to align this door to this reference plane. Select the reference plane, select the door, then lock it. The next thing you want to do, you want to align this door to this reference plane. Okay, so let's lock it and check if the angle is still working, but I don't think so. By locking, let's check. So the angle, for example, open it by 20 degrees, hit apply. So the constraints are not satisfied. This means we are not supposed to lock this door from here. So what are we supposed to do? Because we have to make sure that whenever we move this cabinet, the door must go with this cabinet as well. So what we have to do, we have to go back to where so let's try another thing here. Let's first give a formula to this door and offset it by, let's say, 20 millimeters on both sides, so that we make it 40 millimeters, so the door will be able to be opened, and not go beyond our cabinet. So let's go to the family types, then to the door width, and give it a formula that the door width will be equal to the width of the shell, which is called width minus 40 millimeters. Hit apply. So as you can see, this is how the door will be offsetting, but I think 40 is a bit too much. So let's go back and, for example, offset it by 10. That means 5 millimeters from one side and 5 millimeters from the other side, so that the spacing will look realistic, not too much and not too small. I think 10 millimeters works perfectly. So let's change the width of our cabinet shelves, or the lower cabinet of our kitchen, for example 70 centimeters. Hit apply. So you can see that the door is already in a system. It is changing with the shell of the cabinet. So we are good to go. Bring back to 60 centimeters, hit apply. So the door is already in system, as we can see. So the other thing you can do, you can even align this door to this central aligning it to this central reference plane will again bring the constraints which will not allow the door to be opened. So let's go to the 3D view. So we can see that the door is not aligned vertically. So let's go to the front view. Let's choose align, then align our door here to the top reference plane, and so let's align it like this. So where is our door? So our door is here, so it is aligned on one end but not aligned on the other end. So let's do so. Lock it. So what you're going to do, you're going to give our door a formula again, and that formula will allow this door to be moving with this shell whenever we are changing the height of the shell. So let's go to the family types, then go to the height of the door, which is door H, and give it a formula saying that the door height will be equal to the height of the shell minus, so we want to offset this door to have the top offset of 5 millimeters again, so that there will be a visual change or a spacing between the door and the countertop. So let's minus 10 millimeters again. Hit apply. So go back to the front view. So you can see that the door height is only changing from bottom, not from the both ends. So this is because we have locked it at the top. So let's unlock it, go back and redo. So let's align again this door. So what we are supposed to do, we are supposed to lock it from the bottom, lock it, then whenever if we add the formula, the offset will be from the top because the bottom is already locked. So let's give a formula again, the door height to be equal to the height of the shell, the height of the shell minus 5 millimeters, since we're offsetting from one end. Hit apply. So what's wrong? Okay, the name is not the same. Hit apply. Okay, so let's check if what will happen if we change the height of the shelf. Let's have it, for example, on 1 meter. Hit apply. So you can see that the door is moving with the shell. So this is perfect. Hit apply. Great. So what we forgot to add, the countertop here. So what the countertop is going to look like, we are going to add another reference plane here at the top as the countertop. So as the countertop thickness. So let's add the reference plane here, reference plane. So we want to be having a fixed dimension of the countertop, but you can still control it. So let's give it a parameter. So that we can control the thickness of our countertop. Let's add the parameter and call it TH as the thickness of the countertop. So let's go to the ref level. We have to add another reference plane here for the front offset of the countertop, so that the countertop will not be flashing at the front with this door, it will be a bit extended. So we need to have this reference plane here. Let's call it, so let's give it a specific offset, and this offset I want to have it at 25 millimeters from the door attachment. But with this we will be having a countertop which will flush with the door, and that's not what we want. So let's keep 50. Let's keep 50 millimeters for, okay, like this. I think this one is great, but again 25 is a bit too much. Let's have 35. Let's have 35. Okay, sorry for that sound. Let's have 35, so that the countertop will only be offsetting 5 millimeters from the door. Then let's lock this one. Then we have to go back to the left view so that we can be able to draw the profile of our countertop. But I feel like 35 is very low, very small number. So let's have 50 millimeters. I think it's okay. Then lock it, go to the left view. Okay, then create extrusion. Let's use this rectangle. Okay, then let's use the start end radius arc so that you can have something like this. Let's say okay, then trim these lines, delete this one. Okay, we'll be having something like this as our profile. Hit finish, go to the front view, so you can see that this, so you have to change, we have to move this countertop so that you can be able to lock it here. So lock it, move it again and lock it. So locking it like this will help us to have a system where this countertop's width will be the same as the width of our lower cabinets. So let's change this thickness to the realistic one, for example 25 or 30 can work. So th let's give it 30 millimeters. Hit apply. So the constraints are not satisfied. What's this supposed to mean? Okay, let's see. So what's the problem? 30 millimeters. Hit apply. So let's try to remove the constraints. Okay, so what's the issue? So let's rock this to 30. Okay, then rock it and remove the parameters. Let's delete this parameter. Okay, hit OK. Then let's check the 3D view. So this is how our cabinet is looking like. So I think this offset might be small, this door offset. We can try again, go back to the formula of door height and minus 10 millimeters. Hit apply. So this space is where someone will fill in the hands to open the door. So we have to add the material of this countertop to the parameters. So click the countertop, then add the parameter and call it countertop. It's okay. So this is our lower cabinet. Okay, then our lower cabinet is fully parametric. We've already checked that. So what you have to do is to save this family. Then after saving it, we have to add it, to load it into our project, which is called the linear kitchen. Hit OK, save. So this is our lower cabinet. Let's add it here. We will check the alignment later after accomplishing the modeling of all types of the cabinets that we want. So this is our part of the lower cabinet, our first cabinet. So let's go back